In question 17, we are asked to find the instantaneous velocities of the same tennis player in question 7, but specifically at the moments in time of 0.5 seconds, 2 seconds, 3 seconds, and then at 4.5 seconds. The concept in this is instantaneous velocity. Please make sure you try and identify all concepts as you begin to do problems. Well, instantaneous velocity can be found by finding the slope of the line. The slope of the line on a position versus time graph at a specific time. Okay, so for part A, we want to know the average velocity, or the instantaneous velocity, at 0.5 seconds. Part B, we want to know the instantaneous velocity at, where is it at? 2 seconds. Part C, we want to know the instantaneous velocity at 3 seconds. And part D, we want to know the instantaneous velocity at 4.5 seconds. Okay, so here's how we do this. We focus on the time, the specific time. You go to the graph. In this case, it's the same graph we used for question 7. Now I'm going to focus on that time of a half a second, which would be right here on the graph. Then what I do is I go up to the graph at that instant in time. That would put me right here. This is part of this first line segment right here. All we need to do is find the slope of a tangent line at that particular time. Now it turns out that the tangent line in this case is the entire line from 0 to 1 second. In other words, the instantaneous velocity at a half a second is the same as the average velocity for that whole time interval. And we can use the slope. We can either go up 1 over a half, or over a quarter. We can go up 2 over a half. We can go up 3 over 3/4, or we can go up 4 over 1. Any of those values would get you a consistent slope for the instantaneous velocity at 1 second. I'm just simply going to do 4 over 1. At 2 seconds, well, 2 seconds is right here. And 2 seconds, you'll notice, occurs and is part of this particular downward sloping line segment. In which case, we could have a slope of down 2 over a half, down 6 over 1.5, down 4 over 1. Many different ways that you could characterize the slope in that way. I'm going to go down 4 over 1 as a very easy way to go ahead and get that slope. So the slope of the line at 2 seconds is that downward slope of -4 meters per second. At 3 seconds, well, 3 seconds here, we go to the graph, we can see that it's on this flat line segment right here. Well, the slope of a flat line segment has no rise over 1.5 seconds, meaning 0 instantaneous velocity, not going anywhere. And at 4.5 seconds, well, that would be right here. That is the upward sloping graph right here, which has a slope of up 1 over a half or up 2 over 1. for an instantaneous velocity of 2 meters per second.